So the big picture for this lesson is exponential growth functions. Exponential growth functions increase at an increasing rate. So the graph of one looks something like that. And in terms of integer coordinates, you're repeatedly multiplying by some number called the growth factor. And your function would be y equals a b to the x, where this b value is your growth factor. And the a is your initial amount. Another way to write this is y equals a times 1 plus r to the x power, where r is your growth rate. And yes, 1 plus r makes your growth factor. So there's some examples of evaluating exponential growth functions and also modeling exponential growth functions. And you can model by hand or by using a calculator. And sometimes you're given the initial amount and the growth factor, and sometimes you need to solve for them. And there's a special application for investing money, and it's called the compound interest formula. And this is used to determine investment over time. So an example would be, let's say you invest $4,000 and the interest rate is 5% per year, and you're going to invest it for 10 years. And the rate is compounded monthly. Well, you can figure out how much money you would have after 10 years using this formula. This is the initial amount right here, P, the principal. You'd put the $4,000 there. The R is the interest rate of 5% or 0.05. The N is the number of times it's compounded. In this case, monthly, you would put a 12 here and here. And T is the time in years, so you put the 10 here. So in this lesson, you're going to be asked to create some models for exponential growth function situations and also to do some interest calculations and just dealing generally with exponential functions. So that's the big picture.